Welcome to my YouTube channel Madan Ananth Mathematics. Today I am going to start with a small topic infinite geometric progression of chapter number 9 of class 11th sequence and series. So let us discuss some learning objectives of this video. At the end of this video you are able to find infinite sum of a GP with a condition on R and you are able to solve problems based on infinite GP. First of all, I am going to define what we mean by infinite sequence and an infinite series. A sequence an having infinitely many number of terms is called infinite sequence, and the corresponding sum a1 plus a2 plus a3 so on is called an infinite series associated with infinite sequence. The question arises, is it possible to find out the sum of infinitely many terms of a sequence? If it's so, how? We even don't able to find out the sum of infinite natural numbers. The answer is yes. We are able to find out the sum of infinitely many terms of a GP with a condition R. So let us suppose AR square, AR cube and so on be an infinite GP with the condition on R. Modulus value of R is less than 1, or you can say R is greater than -1 and less than 1. Here we already know the sum of n terms of a GP with the common ratio R, and the first term A is A times 1 minus R raised to the power n upon 1 minus R. As we assumed R is greater than -1 and less than 1, so we'll start with an example. I assumed R is equal to 0.1. You can assume any other value that lies between -1 and 1. Here I am going to discuss only one value of R. If R is equal to 0.1, then R square will be 0.01, R cube is 0.001, R raised to the power 4 is 0.0001 and so on. Here you can see, as I am increasing the index of R, the corresponding value are approaching to 0. Approaching to 0 means the number we are having is very near to 0. It is as close as one can please. So it means we are thinking of large and larger number, then the corresponding value of Rn will be very near to 0. So we can assume it is 0 only. For the larger value of n, this Rn will tends to 0 and the numerator will be A only. I can say the sum of infinitely many terms is equal to A times 1 minus R, provided modulus value of R is less than. I hope it is clear to you. So let us discuss one question. Here we have a GP, infinite GP, and we have to find out the sum to infinity. You can see the first term of this GP is 4 and the common ratio is 1 by 3. You can easily check modulus value of R is less than 1. So we are able to apply the formula S is equal to A upon 1 minus R. Substituting the value of A and R and simplifying, you will get 6 as the sum. The next question, we have to prove that 3 raised to the power half into 3 raised to the power 1 by 4 into 3 raised to the power 1 by 8 till infinity is equal to 3. So we are going to start with the left hand side of this expression, and we already know if bases are same, then we can add the index. Adding indexes, we have 3 raised to the power half plus 1 by 4 plus 1 by 8 and so on. Here you can see this is nothing but an infinite GP with the first term half and the common ratio is also half, and the modulus value of R is less than 1, so we are able to apply the formula in the power of 3. Applying the formula, S is equal to A upon 1 minus R. We will have 3 raised to the power half upon 1 minus half. Simplifying, you will get 3 raised to the power 1. That is same as 3 only. So we are done. In the next question, we have x is equal to 1 plus a square till infinity, provided modulus value of a is less than 1 and y is equal to 1 plus b square so on till infinity, modulus value of b is less than 1. Here you can see both x and y are infinite GP with the first term a and the common ratio a and b respectively with the condition on a and b. So we are able to find out the value of x and y using the sum of infinitely many terms of a GP. So x will be equal to 1 upon 1 minus a and y is equal to 1 upon 1 minus b. Simplifying and writing a and b in terms of x and y respectively, we have a is equal to x minus 1 upon x and b is equal to y minus 1 upon y. Then we have to prove this expression. So we'll start with the left hand side. Here you can see this expression 1 plus ab plus a square b square so on is nothing but an infinite GP with the first term 1 and the common ratio ab. To apply the formula of infinite sum, we need to check whether the modulus value of the common ratio is less than 1 or not. So considering modulus value of AB, that is equal to modulus value of A and modulus value of B, both of which are less than 1, it is given in the question. So the modulus value of AB is less than 1, so we are able to apply the formula. So according to formula, the sum will be equal to 1 upon 1 minus AB. We already have value of a and b in terms of x and y. You can directly substitute the value of a and b here and simplify the expression. You will get the right hand side of this given expression. So we are done. Here are some questions for home assignment. You can pause my video and note it down. If you find any difficulty in solving these questions, then you may ask your doubt in the comment section. Or if you are having any doubt related to the content, then you can message me in the comment box. I will definitely help you. Thank you so much. If you like this video, then subscribe my channel, like my video and share with your friend. Thank you again.